Hello and welcome everyone. Our today's question is very interesting. Question name is trail of 1. Suppose we have a variable n and its value is 2. So just write its bits, so 0 1 1 0 1 1, and in that I have to tell how many consecutive ones are there. So in 2 we have one consecutive ones are there. So the answer is 1. So now I am writing for 3. So in 3, if you analyze in this set, I have just written 0 in front of them, which means this is a set of 2, this is a set of 2 not changed. So in set of 2, the answer is 1, and this is a set of 3, but I have written 1 in front of them. If I write 1 in front of them, just check how many extras consecutive ones are there. So 1 2, so 2, so overall answer is 3. So now I am writing for 4. So in this set, this is a set of 3, but I have written 0 in front of them. So set is not changed. This is a set of 3, and in 3 set we have answer as 3. So 3 answer, and this is a set of 3 also, but I have write 1 in front of them. So just check how many extras consecutive ones are there. So as you can see, 1 2 3 4, and here 5. I have divided this into two portions. I will tell you why. So if you observe, this is a set of 3, but I have written 1 in front of them, and this is a set of 2, but I have written 0 in front of them. So this is a set of 3, and this is a set of 4. This is a set of 4, and in this red area, this is a set of 3, but 0 in front of them is written. So the white area is a set of 2. So just check how many consecutive ones are there in a set of 2. In a set of 2, we have one consecutive. So 1 here. So now the consecutive ones for 3, I have written 1 in front of them. This is a set of 3, and I have written 1 in front of them. So just check how many consecutive ones are there. So I have divided this area in half portion. So for value 4, for value 4, I have divided the area in half. So for 2 to the power I minus 1, if I write for 2 to the power 3, which is 8. 8 means this portion. So for 4, as you know, this portion is 2 to the power of 4. So this place 2, this place 2 portion, this place 2 possibility, and this place 2 possibility. So overall, it is a 2 to the power of 4, and this is a 2 to the power of 3. And if I further divide, this is a 2 to the power of 2, or I can write 2 to the power of I minus 1 by 2. The answer is same. So the answer, the overall answer for 4 is 5 here and 3 here. So in total 8. So 8 I have written. I will tell you for 5 also. So now I am writing for 5. For 5. So this is a set of 4 and I have written 0 in front of them. So in set of 4 we have 8 and this is a set of 4 but I have written 1 in front of them. So and this is a set of 3 and I have written 0 in front of them. So just to check how many consecutive ones are there in a set of 3. So in a set of 3 we have answer as 3. So in this set we have 3 and in this set I have to check for this set. So if I write 2 to the power of 5, so overall this set, then if I write 2 to the power of 5 minus 1 or I minus 1, then which means this set, and if I further divide 2 to the power of I minus 2, so which means this set, and 1 2 3 4 5 6 7 8, 8 are there as you can see, 1 2 3 4 5 6 7 8, so 8. So 8 plus 8 16, 16 plus 3 19. So 19 answer is there. You can check for 6 also. So I'm not gonna write for 6. So I will tell you the code now. So I have to also consider the modulus operation. So just write the base case. For n is equal to 2, the answer is 1. For n is equal to 3, the answer is 3. As we know, now I will build a DP of long data type. Just fill the value of 2 and 3. Now run a loop from 4 till n. Now for dp of I have to consider dp of I minus 1. As I already told you, for 5 I have to consider solve n minus 1 or this solve n minus 2. For 5 I have to consider 4 and 3 set. So n minus 1 and n minus 2 and n minus 2, and I have to also consider a to the power of b means 2 to the power of I minus 2 or 2 to the power of I minus 1 by 2. So in this function, power function, I have already made a video on power. So I will link the video in the I button. So if first we have answer as 1, and if b means power, so in this I have to find a to the power of b. If b is there, b is greater than 0, then just check. If b is a odd, then multiply answer with a, then divide b, then multiply a. Now b is even. Now just multiply a and take the modulus, then at the end return our answer. Now I have to consider power of 2 to the power of I minus 1. So this value I have to also consider, so which means this set I minus 2 set, and just apply modulus and here modulus. Now at the end return dpn but with conversion of integer. So its time complexity is order of n and space complexity is order of n. I hope you find this video helpful. If you find this video helpful, consider subscribing this channel. So thank you all for watching this video.